Hello everyone, welcome back to the introduction to rocket engineering, and today I would like to introduce how to design a rocket. This is part 1. We know that the rocket is a very complicated system. It's basically a system engineering. And we have engine system, or so-called motor. It provides the thrust, and we have the structure over here, and of course we have nose cone and the payload and the fin. Of course, we introduced the sounding rocket for now, which is smaller, and the altitude will become less than 100 kilometers. And today's point is I would like to introduce how do we design such a rocket. It's a very complicated system. How do we utilize the system engineering to design the rocket? Well, it's not so hard as you think, because we will use physics. As you know, we learn physics as a high school student. Physics is a father of all engineering fields. So here I would like to mention the physical terms as the first part of this introduction, also called the professional nouns. Take the engine as an example. Well, of course, you might heard about all these special terms that no matter in the technical report or some audience, some reports, some reference, but do you really know what's the meaning of this, including the ISP, impulse, total impulse, burn time, thrust, sea level thrust, vacuum thrust, propellant, engine performance, engine curve, and so on? Do you realize what each term's specific physical meaning? Well, I have convinced that when I first time to get in touch with a rocket, this field, I quite confused about all these special terms, because I don't understand what does that mean. For example, the ISP, it has units of kgs of s. What does that mean? Oh, we have impulse and the total impulse. What's the difference? The thrust, I know it has a unit of the force. We can have Newton or kg W. And about the burn time, oh yes, of course, from the meaning, it's supposed to be the fuel. How many times we burn out the fuel? But there are a lot of physics behind it. Do we really understand that? If you do not, I suggest you try to spend some time to realize each term. That's real meaning. Okay, real meaning. Dig it. Not just, oh, I see. No, it's not. Fully understand, totally understand the meaning. It's really important to help you to understand how does the engine works, and why we need all these special terms to describe the engine performance. At the end, you will see how the engine curves really helps us to design a rocket. Well, of course, we didn't say if we use a system engineering to help us to design rocket, we have to first, and also the most important part is how to design the specification. For example, how high I want to fly. Take as a sample 3,000 meters or 3 kilometers. Okay, this is my specifications, and the total weight of the rocket cannot over 30 kilograms. For example, this is my specification that I have to require. I have to make this requirement. But before doing that, we have to know a lot of the choices that we have to make. So before you really give your rocket specifications, then you have to realize all these physical terms. And please notice that I only make the example of engine. Don't forget we have fins, we have structures, we have nose cone. Well, I don't mention the pedals here because it depends on what kind of scientific research that you want to do in a sounding rocket. But we have a parachute if you want to recover your experiment result. All right, or avian communication system. Okay. So when it matters to talk about the physics, well, I really know that everyone doesn't like physics. All right, everyone don't like physics as far as I know. So I meet very few people that really like physics. They join the engineering department because they don't like physics. But you have to really understand the physics is behind every mechanism, behind every mechanics, and is the fundamental of all subjects in engineering department. So as you know the background of knowledge, you can see how the technique is showing in front of you. So if you want to become very good engineer, I have to say that you have very familiar with physics, especially the very fundamental one. I don't mention about the quantum physics or plasma, some sort of the advanced physics. I only mention about the Newton law. That would be enough. Or maybe some energy conservation sort of things. So the background knowledge are so important. It's not only to know the professional nouns, but it's also to know the definition and the relations to each others. I mean, each others here is included the each other subsystems in engines, for example. Do you know the nozzle's shape will affect the thrust at the end of your performance? Well, this is called the subsystems. So it's all based on the physics law. Let me show you an example. Well, we all know that the thrust is used against the weight of the rocket and also the drag. So we can write down basically according to the Newton's law, the thrust minus the drag force and minus the rocket's weight equals to 0. Oh, we say it. Because I want to fly it, right? I want to have accelerations up to the sky. And all these terms, this is a very simple physics. You have learned that from your high school. So it's not so difficult. But we can see that, let me change the color here. The thrust depends on how heavy of the rocket, the heavy of your rocket. And I have to say that, except the propellant, the most weight of the rocket comes from the structure. The structure means the structures support all the systems of the rocket, and also your payload, your parachute, and your fin. So the structure weight is very important, and we have a special term called it a structure ratio. And this is a structure ratio can help us to determine how much up or limited, or we say the upper limit of the structure weight that we can have to this rocket. You cannot overweight it, otherwise we cannot have enough propellant to generate enough thrust to let the rocket lift off. So that's a point. And the other point is the drag. The drag is dependent on the shape of the rocket, especially the nose cone, and of course the fins provides a part of the drag as well. So these are the system engineering, because as your nose cone, you choose a different kind of nose cone, it will generate a different kind of drag, even a little bit of lift. But sometimes it will introduce some difficulty to, for example, if you want to if you want to get rid of the nose cone, to let your equipment, scientific equipment, to do the experiment, but that will become the problem to eject your nose cone. So we have a mechanism. Sorry, it's my cat. She's quite weak in the middle of the night. Yes, it's active time now. You have the very strong connection to attach the nose cone, but you have to let it eject as you want. So this structure mechanism design is very important. All right. So this concept is well extended to the stage separation. If we have the more than one stage of the rocket, for example, 2 stage or 3 stage. So there's a similar concept. Okay. So this example just give you the concept. The more propellant give you more thrust, but it also increase the weight of the rocket. So we have to do this ratio of the weight and the thrust. That's very important in the design of the rocket. Okay, so in general speaking, physics concept helps a lot in engineering. Well, basically, I will say in all fields. Please follow the statement as I write below, because that's my experience. Doesn't mean it's all right, it's all correct, because it's my own personal opinion, but give you as a record. First, you have to make sure. Sorry, that you said not right. You have to make sure that you understand. Oh, sorry, wrong spelling. Understand the physical principle or physical learned that you meet. You have to really understand the condition that you meet, what kind of physics that you need. Well, as we see, it's not too difficult. It's about Newton's law, and later on, if you really want to know more about combustion or how to lift a rocket, you probably have to know the momentum conservation. And I introduced this in the former videos. If you're interested in that, please to see that videos. Okay. So please understand the rocket techniques terms. I repeat this again because if you don't know what ISP means, how could you design the rocket? Well, I don't know, honestly. All right, or even the structural ratio. Sorry, but I had poor handwriting. All right. And this is also very important from my own perspective because do not rely on software, for example, the Open Rocket or Open Motor, because if you use that or you to rely on these kind of softwares, then you will never know what's the physics or techniques they used behind it, right? You will miss the point to know how to calculate the trajectory. It will miss the point how to design the propellant or to see how the propellant works. Because they are package business software. Well, my suggestion is try to write your own program, either trajectory or a combustion part. Well, of course, we can have other software. We can add other programs. For example, you can do the simulation by using the ANSYS, or you can write the Python code to do the trajectory. That helps you to realize more in the process how the rocket really fly in the sky and what the combustions really happened in the combustion. So that would be great if you can really write your own program. But I know it takes time. Well, so-called time is money, but if you don't do this now, well, I'm so sure that you will pay a lot of what's that called? You will pay more time to know all the things behind it, because you basically, if you always do the trial and the error, then you are not your background knowledge is not just like go up like this. You have a very solid background knowledge. It will become like this. It will become so unstable. All you know is constructed under very, very unstable condition because you use too much software. You don't know about the physical turn. You even don't realize what the physics behind the rocket science. So have a simple one simulation or simple one program and make it become more practical if you need by including more actual models. Well, let's go step by step, and we will introduce that in our following videos. So the concluding remark will be the modeling, simulations, and analysis are the best ways to learn how to start design a rocket rather to use a trial and error, because trial and error it might be easy to start, but I'm guarantee you that you will make more money and more time to go back to find out the problem. Because you don't know where it goes wrong. All right, this is my suggestions, and you don't really have to follow about this because this is how to design rocket part 1, and we will have part 2. I just want to mention you that how important the physics is in play the role in designing rocket, and in the part 2 I will introduce you to how to use the system engineering to design the rocket, and I will show you a very horrible design example that if you don't use this way, then you will make a problem. Okay, thank you for listening. We'll see you next time. Bye bye.